Welcome to the third part of Unit 10. In the first two parts of this unit, we have been focused on the concept of work, and I've mentioned energy along the way because they go hand in hand. In this part, we're going to focus more on energy, and then in the next part, we're going to tie work and energy together. So there are many types of energy. Well, you just saw that one, so I will put it up there, kinetic energy. Okay. Along with kinetic energy, we have potential energy. And these two are broadly referred to as mechanical energy. Okay. Well, you might also be thinking of things like solar energy. You may be thinking of nuclear, if I could spell it, nuclear energy. You may think of geothermal energy. You might think of thermal energy. Right? All of these are types of energy. I'm not going to dispute it. But for the purpose of this unit, we're going to focus on mechanical energy. So there are three types of mechanical energy, one kinetic and two potential energies that we're going to define here. So kinetic energy is energy contained in motion. And by definition, you calculate kinetic energy by 1/2 mv squared. So this is technically the velocity squared. Okay. The instantaneous velocity squared. But remember from way back when that the magnitude of the instantaneous velocity, I'll even make a little note here, means that this is actually the speed. You can consider it as 1/2 mass times the speed squared because it's the magnitude of the instantaneous velocity that gets squared. Okay. Next one, gravitational potential energy. Gravitational potential energy is energy that is stored in an object, so it has potential to become kinetic. That's where that name comes from. And you store it in the object by raising it or lifting it. Okay. So GPE, by definition, is mgh, mass times the acceleration due to gravity times height. What do we mean by height? Well, we define some location as 0 height and another location as a height above that, and that would be your height. Technically, your height could be down below 0, which would make this negative, which would make all of gravitational potential energy negative. That is not typically how problems run, but they can be run that way. And lastly, we have elastic potential energy. And this is energy that's stored in a spring by either stretching or compressing it. So EPE, elastic potential energy, is given by 1/2 kx squared. Okay, couple things we need to define here. K is known as the spring constant. Now, the spring constant is not a constant like capital G in the last unit was, where it's always the same number. This is different for every single spring. But for a single spring, as long as you stay in the realm where the force is proportional to the displacement, Hooke's law, as we saw in a lab, then K is constant for that individual spring. K has units of newtons per meter. Okay. What is X? X is the displacement of the spring from its unstretched length. Okay. So if I have a spring, boop, 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 and unstretched, it's here, and then I pull it out to here, this could be my X. Or on the other hand, I could take that spring and I could push it in this could be my x, but it's always measured relative to the unstretched length. That concludes this part of this unit. In the next part, we're going to make the connection between work and energy.